A wave is something that transfers energy without transferring matter. And this is all the fundamental stuff that you need to know. So there are two types of waves, two main types. There's transverse and longitudinal waves. Transverse waves are your typical waves that go up and down like this. They have oscillations that are perpendicular to the direction of travel. Examples of transverse waves include electromagnetic waves, that entire spectrum, and water waves. The other type of wave is a longitudinal wave, and those types of waves have oscillations that are parallel in the same direction as the direction of travel. Sounds just like your phone is making right now. Those are examples of longitudinal waves. Ensure that you can label the diagrams of these types of waves. So here's a transverse wave. Notice we have peaks and troughs. Those are the top and bottom points of those curves. We'd also label the wavelength, which, as the name suggests, is the length of one full wave cycle. So nice and easy on a diagram, you can take a look at from one peak to the next peak. Lambda is the symbol for wavelength, by the way. These waves also have an amplitude, which is defined as the maximum displacement. So it's the height of the peak or the depth of the trough from the rest position. So if you take a look at the diagram, the rest position, look how far from the rest position your peak is, that is your amplitude. Not to be confused with the entire top to bottom, peak to trough, because that isn't anything. Next, the diagram of a longitudinal wave. Now the things to label here, again, you can do the wavelength, which will be the distance between the same points on your diagram. So for example, between two compressions. The compressions are the points where you see the lines get nice and close together. And then the opposite of that, where the lines spread out, is called a rarefaction. Not refraction, a rarefaction. Make sure you say it and spell it correctly. That's to make sure it doesn't get confused with refraction, because that's the bending of light, a completely different thing. Last couple of definitions to wrap up. So we know amplitude is maximum displacement, wavelength is the length of one complete wave cycle. There's also time period with a capital T for the symbol. That is the time taken for one complete wave cycle, measured in seconds. And then we have frequency, which is the number of complete waves per second, with a unit of hertz. So waves transfer energy without transferring matter. There's transverse with perpendicular oscillations to the energy transfer direction, and there's longitudinal with parallel oscillations to the energy transfer direction. I hope that clears it up. We'll do some more videos on waves soon. Let me know if there are any other topics that you need clearing up, and I'll make you a video. Keep revising, stay consistent, and I believe in you. You're going to do really well this year. Best of luck.